Okay, so this module is all about pricing and pricing under different circumstances. We're going to start with this video looking at pricing in probably what would be considered an extreme case where the goods are not very differentiated. I guess they could be identical, but they're awfully close if they're not identical, so that the consumer is highly sensitive to prices. And what we want to do is we want to use our game theory tools from the last module and use those to look at if there's intense price competition, what's going to end up happening. So think like agricultural products, oil, those sorts of things where they're identical or really close to it, and you're just going to buy from the low price. So, an apple's an apple, and you're going to buy the low price. So you get pretty intense competition. And it leads to maybe a surprising result, and that's what we want to look at here. And then we'll move from here and we'll look at things like price discrimination and cooperative pricing and those things. So this is all pricing, but we're going to start here with sort of the most intense price competition we can think of. So here's our model. For lack of a better example, let's say that we're looking at the model or the market for streaming media services. So things like Netflix and Hulu and Sling TV and YouTube TV and all of these. And yes, they differ in terms of programming a little bit. Some of them have deals with different networks to carry their shows. Some of them produce their own shows, those sorts of things. But let's just, for argument's sake at this point, say that they all have the same basic programming. So we know, or we can go out and estimate, like we talked about when we talked about estimating demand, the demand for these streaming services. And so I give you sort of this equation right here where we say, okay, there's the demand curve. That's what the demand curve for streaming services looks like. And then we know that their costs are 2Q. So they have some costs associated with providing these services. And so with two firms, we can model this game theoretically. We can pick a number of different prices and we can put it into a table. Okay, so here's a game matrix with all kinds of different prices. Now, we could do this continuous, like I talked about in previous videos, and we just need some calculus, but we don't lose anything by going to a discrete case like this. In fact, when we find Nash equilibrium, we'll say, okay, this is where it's going to be, and the logic will apply whether we're continuous or discrete like we have here. Notice that the lowest price I put here for either firm is $2, because on the previous slide we said their marginal cost is 2 quantity. They're not going to price below their cost, so it seems reasonable to say they're not going to go below $2. So how are we going to fill in this table? Because we know how to solve this table once we get it filled in, we look for best responses. So if you remember from the previous slide, the demand price was equal to 38 minus 3Q, and costs equaled 2Q. Okay, so let's just pick a cell here. Let's say, for example, both firms price at $14. Okay, so if price equals 14, then we can plug that 14 into our demand up here. Sorry, not into Q, but into price. And we would get 14 equal to 38 minus 3Q. If we subtract 38 from both sides, we get negative 24 equals negative 3Q. Q equals 8. Okay, so let's say that there's two firms and they both price at 14. So that's one cell in here. So we're talking right here where we have two firms and they both price at 14. So in terms of how much money they would make, the market quantity would be 8. Since there's two of them, they would each get half the market, so each firm would sell quantity 4. Okay, so their profit for each firm would be the $14 they're charging times the 4 that they sell, minus their cost, which is 2 times 4, And when you calculate that out, you get 48. Okay, so my cell here is going to be 48, 48. If one firm charged $14 and the other firm charged something higher, okay, so either 18 or 20 in this case, the firm charging higher is going to sell nothing. The low cost firm at $14 is going to sell all 8 that we've already solved for. So in that case, their profit would be 14 times 8 minus 2 times 8. So in this case, that would end up being 96. Okay, so we're going to put that. So the low-cost firm is going to get 96. So this would be 96. This would be 96. The high-cost firm gets 0. So that's 0, 0. And then going across here, this would be 96, 0, 96, 0. Okay, and in fact, we can come through here and we can basically say, if you think of the diagonal where they're charging equal prices, everywhere under that diagonal line, this firm is going to be, firm 1 in this example, is going to be high cost. And so they're going to serve nothing. So we end up with a whole bunch of zeros here. And then again, if you think diagonal, everything above the diagonal is going to be sort of a mirror image here, where firm 2 is going to be high cost, and they're not going to get anything. Okay, so we fill that in, and that helps us a lot. We end up with lots and lots of zeros. This should be a 0. This should be a 0. And then we can fill in the rest by just doing the same process. So just at this price, what's quantity, and then calculating out profits directly. Here's what it looks like all filled in with all the different profits. And you notice all those same zeros here. We can then go and notice that the 2 columns, because they're pricing at cost, even the low cost firm is earning 0 because their price is equal to their cost. So we then go through, just like we've done several times before, and we look for best responses. We look for, okay, if this firm does this, what is their best response? So, for example, if firm 2 charges a price of 20, what would firm 1 want to do? So if firm 2 charges a price of 20, firm 1 is going to look down at their options, and they're going to optimize at 106.6. If firm 2 charges 18, they're going to look at their options, and they're going to maximize their profit at 96. If they charge 14, they're going to maximize their profit at 74.6. If firm 2 charges 10, they're going to maximize their profit at 42.7. If they charge 6, they're going to maximize their profit at 21.3. And if they charge 2, technically, no matter what they do, they're going to get a profit of 0. So there's their best responses. Now, before I go through and I fill them in for firm 2, notice what firm 1 is doing. Firm 1, when firm 2 charged 20, firm 1 went 18. When firm 2 charged 18, firm 1 charged 14. When firm 2 charged 14, firm 1 went 10. So firm 1 is basically always going 1 increment lower. They're undercutting the price of firm 2 by just 1 notch. And so that price undercutting is going to be important in a second. So let's fill it in for the other firms. So it's going to be basically a mirror image. So if firm 1 chooses 20, firm 2 is going to choose 18. If they choose 18, they're going to choose 96, 14, let's see, 42.7, 21.3, and then all these zeros here. And so we're looking for where is there overlap. So notice there's overlap here and there's overlap here. Okay, so we're finding 2 Nash equilibriums, one where they both charge 6 and one where they both charge 2. Okay, now think about that for a second. Let me put the next slide up, and then I'm going to argue that of these two Nash equilibrium, there's really only one intuitively. Okay, so we found two Nash equilibriums, one where the firm's earning zero profit, and the other one where they're earning 21.30 each by charging 6 and selling 5.3 units. My argument is, in reality, there's only one Nash equilibrium, because the process that the firms are going through is they're always wanting to be slightly below the other firm's price, because by undercutting them slightly, they capture the whole market. So my argument here, and it should make intuitive sense, is that the table, the only reason we actually have two equilibria is because we're doing discrete. If we did continuous, then when they're charging a price of 6, the other firm would really like to go to 5.99. And then their competitor would go to 5.98, and their competitor would go to 5.97, 5.96. They just continue to undercut each other. We're showing those two Nash equilibrium because it's a discrete case. But if it was a continuous case, they keep having an incentive to undercut, because every time they undercut, they capture the entire market, and so they're going to want to undercut. So the only true Nash equilibrium of this game is actually the one where they earn zero profit. And depending on how long it's been since you've taken a Principles of Econ class, zero profit is actually a perfect competitive outcome. So intense price competition, this is sort of a perfect competition outcome where they earn zero profit. They actually undercut each other and drive profit all the way down to zero. Okay, so real world complications that mean we're not probably often going to find zero profit exactly. Cost differences that maybe stem from technology, all kinds of different factors, location, minimum wage, all kinds of things impact firm costs. And firms are only going to undercut each other as long they're only going to go down to their costs. They're not going to go below their costs and start losing money. So if they have different costs, then the high cost firm is going to undercut the low cost firm until the low cost firm won't copy them. So, like, for example, let's say in that previous example, one of the firms had a cost of 2 and the other had a cost of 14. Well, we would find that the low cost firm, their optimal strategy would then be to price at like $13.99 to undercut the one firm by a cent under their cost. That firm won't copy and undercut or even match their price. And so the low cost firm will be able to earn profits because the other firm won't be able to keep undercutting and matching. So cost differences can change this outcome. Product differentiation, which will be a topic in another module, can change this outcome if the goods aren't identical, if there's branding, if there's some kind of difference between them so that customers prefer one over the other. Collusion could also, and that'll be yet another module even later in the term, could come into play here in terms of maintaining sort of a higher profit level than zero. Some things, some business practices that stem from these markets with intense price competition. Price matching. Okay, so if you advertise that you won't be beat, you'll match any competitor's price, that sounds super competitive. And we'll keep coming back to this business practice several times because it fits in several different areas. It sounds really competitive, like, hey, we're all for our customers and we'll never be undersold. In reality, when they announce that they will not be undersold, they're telling their competitors that if you undercut us, we're going to match you. And so the competitors no longer have an incentive to undercut. If you think back to that table, undercutting, they captured the entire market. Well, here, if I undercut, I'm still only going to get half the market because my competitor is matching. So price matching removes the incentive to lower price and should maintain higher profits. As we saw in the game theory or the applying game theory to business video, inducing brand loyalty, frequent flyer programs, loyal customer programs, grocery stores, you put in your phone number and you get, gas reward points or whatever it happens to be. we saw in that video how that can induce some brand loyalty and lessen price competition. And then randomized pricing makes it harder on consumers to know who's the lower price, and they don't want to go shopping around then. If you randomize price, that's not a real common one, but there are some case studies out there that talk about randomized pricing as a way of sort of lessening this price competition.